Hello everyone. Today I am going to explain the sixth problem of AtCoder beginner contest 267, which is exactly case tips. So I have not solved this problem during the contest time, and as you are requesting to upload the editorial, that's why I have gone through the editorial of AtCoder and tried to understand the editorial. And today I am going to explain the editorial to you and the code of the editorial. So what is the given problem to us? So the we are given a tree of n vertices. Let's say this is the tree, and we are given q queries, and each query will be given like ui and ki, and we have to tell that that if there exists any node from ki distance to ui, so we have to return that node. So let's take the example here. So the example is 1 2 2 3 3 4 3 5. So let's draw the graph now. 1 2 2 3 3 4 and 3 5. And what is the queries given to us? The first query is 2225333. So let's write the queries now. 2253 and 33. So that means we have to, in the first query, we have to return any node which is at distance 2 from 2. So there are two nodes which is at distance 2 from 2, which is 4 and 5. So we would either return 4 or 5. So we could either say 4 or 5. So now we have to return in the second query the node which is at distance 3 from 5. So 1 is at distance 3 from 5, so the answer will be 1. And node which is at distance 3 from 3, third query, there is no node which is at distance 3 from the 3, so it will be -1. So answer could be 4 1 minus 1 or 5 1 minus 1. So now let's go into the editorial. So let's say editorial, this is the editorial of if. So now I will you can go through this editorial. Now I will explain the editorial to you. So according to the editorial, so you know the diameter of a tree. The diameter of a tree is the length of the longest path between any nodes of the tree. So let's create one tree now. Let's say this is 1 2 3 4 5 and 6. So the longest path in the tree, like between any two nodes in the tree, is this, from 6 to 3. So this is the diameter of the tree. So for calculating the diameter of the tree, you can go through like it could be in out dp solution. In out dp would overcomplicate the solution. The simpler approach will be like dfs from the root node. Let's say our root node is 1, so we'll dfs from the root node and find the node with the maximum distance from 1. It could be either 3 or 6. Then again start a dfs from 6 and find the maximum node at the, like, maximum distance node from 6, which will be 3. So 6 and 3 will be our corner points of the diameter. So that's what that's how we find the diameter of a tree. So first we will find the distance from one, distance from root, and then we will find the maximum distance node. Let's say this max dis, and then we will dfs from max dis, and we will get our two corner points. So let's say the two corner points are L and R. So here L is 3 and R is 6. So according to the editorial, so what we are doing is that, let's say we are given an query ui comma ki. So there exists a node like at distance ki. If it is possible for if this query is not equals to -1, then there exists a node between the path L to ui or R to ui. So let me explain it again. So let's say uh, distance of 2 from 4. So distance of 2 from 4 is either 2 or 5. So it 2 exists in the path from L to 4. L to 4, the path is 3 2 1 4. So answer will be 2 here. So we'll store the path from L to ui, and again we'll just return the, like, um, let's say the path length is, let's say, n. So we'll return n minus ki length element from the path. So we'll return just path of ni minus n minus ki. So 2 will be returned from this. So this is dfs from L, and if we do dfs from R, our path will be like 6 5 1 and 4, and we'll return 4 minus 2, so 5 will be returned here. So we can either do dfs from L or either do dfs from R. and we are storing path from array to ui, and we are just returning in minus ui length element from here. So you may argue why it is happening, like why it is always the case. So let me explain it with contradictions. So let's draw the graph again. So let's say this is a root node. Let's say call this r, and sorry, that is already an r node, so let's name it r root. So let's say this is l, and this is ui here, ui, and let's say this has some children here, and let's say this is ri. So let's say this is our tree, root l ui ri. So you are saying that your contradiction is that there exists a path in the like child of ui at distance ki, but not in the path from l to ui, or not in the path from r to ui. So that's you are saying. So there does not exist a node from L to EI, or there does not exist a node from R to EI. That means that the length of the length of the path size from L to EI is less than like from L to UI, path of L to UI is less than k, and path of R to UI is less than k. Okay, that's what your argument is saying. Okay, so path of L to UI is less than k, and path of R to UI is less than k. So that means and here let's say the node is vi, and the distance between ui to vi is k. That's you are saying. Now distance between ui to vi is k. That means the distance between root to vi is greater than equals to k, because ui could be the root also. So distance between root to vi is greater than equals to k. Then that means that our diameter should be this, like ri to root to vi. So our diameter should be ri to vi, or it could be li to vi. So that like, so your contradiction is invalid, because L to R is the maximum path here. And you as per your argument, if there exists a node vi in the like subtree of ui, which is at distance k from ui, and there does not exist any node in the path from L to ui and R to ui in the like the length of the path from L to UI is also less than k, and length of the path from R to UI is also less than k, and there exists a node in the subtree of UI which is at distance k. It is invalid case. So it is always true if answer exists, then the answer would be in the path of L to UI, or the answer would be in the path of R to UI. So that's what I have proven you. Now let's go into the solution code now, and I will explain the solution code to you also. So let's go to here. So integer l is get farthest 0, so they are considering 0 as the root node. So just what we are doing, we are just finding the r node here, or l node you can say. L node is the maximum distance node from root. Let's say here it is 7, and then we will again do dfs from this 7. Let's say we will again find the second farthest node, so we will mark it l and mark it r. So that's what they are doing here. It is common diameter finding code. So they are finding l and r here, and again now they are doing dfs from considering root as l and r. So they are considering both l and r as a root, and they are doing dfs, and they are just finding, let's say there is this a node from, let's say there exists in query qi, which is ui comma ki. So they will check do dfs from both l and r, and when they are at node ui they are checking. So let's say when they are at node let's say they are at node q, sorry, they are at node u. So they are checking that answer of q equals to path of integer of path dot size minus k plus 1, that I have already explained. They are using zero based indexing, that's why they are incrementing the value plus 1 here, and they are just pushing the value of u in the path. So path is nothing but like when we are doing dfs. So the path value of here, it will be for 2 it will be 4 2, for 1 it will be 4 2 1, for 5 it will be 4 to 5, like that. I hope you got my explanation. If you have any doubt in the code, you can ask me in the comment section. You can go through the code from the editorial. please like the video and subscribe to my channel. Thank you.